Hey everybody, welcome back. In this video we've got another voltage divider circuit. Let's take a look at what's going on here. So we have a 9-volt battery. This is the positive terminal and this is the negative terminal. So the current is going to flow out this way through this resistor and then through this resistor, and it's just going to go head to tail through each resistor because each of these resistors are actually connected in series, and we're going to come back to the negative terminal of the battery. So to calculate the equivalent resistance, it's just the sum of each of the individual resistors that's in series. So we find that the equivalent resistance is equal to 12 ohms. So from the battery's perspective, that means that we could basically just cut the wires like this. And then if we just connected on a different resistor, just a single one that was 12 ohms, that's the same thing as having this whole circuit over on the left. So knowing that the total current is the same everywhere in the circuit because this is just one series loop means we can take Ohm's law, which is V equals IR, and rearrange for current. So we have I is equal to V over R. Now we can plug in the values that we have here. So voltage is 9 volts and the equivalent resistance or total resistance that the battery sees is 12 ohms. And 9 divided by 12 just means that our current is going to be equal to 0.75 amps. And again, this is the current that's flowing through every single resistor because there's only one path for it to follow. So we can find the voltage drop of each resistor using Ohm's law again with V equals IR. And current is going to be 0.75 amps in every case. And we just multiply it by the resistance of each resistor to find the voltage drop across that resistor. So taking a look at the first resistor here, we have 1 ohm. So we can just write that in. And 0.75 amps times 1 ohm just gives us 0.75 volts. Then when we move over to the next resistor, we have 2 ohms of resistance. So what we can do is we can just erase what we have here in the expression and replace this with 2 ohms for this resistor, and 0.75 times 2 gives us a value of 1.5 volts. Then moving to the next resistor, as we come around this way, we have 0.5 ohms. So again, we can just update our expression here because we're going to have the same current in every single one. So we can set this to 0.5 ohms, and 0.75 times 0.5 gives us 0.375 volts. And for resistors like this, the current is always going to be entering through the positive side and out the negative side. I'll put a link up in the top right corner to the video on passive sign convention for circuits, which talks about the polarity of resistors. But otherwise, we'll just continue on with this. So when we get to the next resistor, it's 3 ohms. So we can come in here and reapply our expression again. So we have 3 ohms, and 0.75 times 3 is 2.25 volts. When we come around the corner to the next one, we have 1 ohm of resistance, and we already calculated that before, which is 1 times 0.75 amps is 0.75 volts. And then the next resistor, let's update that one as well. So we just have 1.5 ohms, and 1.5 ohms times 0.75 amps gives us 1.125 volts. And then the very last resistor, it's 3 ohms and it has a current of 0.75, but we already did that calculation up here, so it has a voltage drop of 2.25 volts. And then when we come around to the battery, we enter through the negative terminal and out through the positive terminal, and it jumps up by 9 volts. So if you actually go around the circuit and you add all of the individual voltage drops, so 0.75 plus 1.5, adding all of these around, you're actually going to find that that sums to 9 volts. So the battery is supplying 9 volts to the circuit, and then we're dropping 9 volts basically split up everywhere else. It's basically divided across all of the other resistors. So that's why we call this a voltage division circuit. Like every resistor has the same current, but the total voltage drop, from the perspective of the source, is divided among all of the resistors. So anyways, I hope that example was helpful. Again, just to see one more simple example of just a simple voltage divider circuit, and I'll see you guys in the next video where we'll start talking about current division.